Skywatch Media News for April the 2nd, 2020. If you happen to reside along the 1,680-mile span that makes up the U.S. Gulf Coast, then you understand the threats that this region of the country realizes from powerful hurricanes and the storm surges and floods that often accompany them. These forces of nature occur on a regular basis from one year to the next, but we never know just how threatening they are until they unleash their fury. Now it appears that another real threat exists near a sizable trench located in the Gulf of Mexico, about 40 miles off the mouth of the old river delta called the Mississippi Canyon. It is from this specific region that a potential 15-foot wall of water could scurry across southeast Louisiana if a significant underwater landslide were to occur. But unlike the ample hurricane warnings provided residents along the Gulf Coast, a tsunami warning would come with only an hour's notice, not days. Subsurface landslides in the Gulf of Mexico have occurred about once every millennium, and the time frame for the next big event in this region is about to expire. Although an event of this caliber is considered low probability, it is nonetheless very credible. In fact, the National Weather Service has discovered evidence of prior landslides in the Mississippi Canyon that could lead to a significant tsunami. This would be accomplished by the dislodging of canyon material that would then lead to water displacement and the buildup of a large rolling wave that could hit the Gulf Coast within a very short time frame. This computer simulation displays a tremendous landslide along the Mississippi Canyon that generates a wave between 6 and 65 feet across the U.S. Gulf Coast. A tsunami generated by subsurface dislodgement may not be that noticeable in the open Gulf, but as the wave reaches the shallower waters, the wave will rise up dramatically. This, of course, is just a hypothetical simulation of what could take place. But if an event of this magnitude were to occur, and you happen to reside along the coastline of Louisiana, a wall of water as high as 15 feet or larger heading in your direction is certainly a devastating prospect. So, what could cause a major tsunami in the Gulf of Mexico? It could be strong seismic activity measuring 7.0 or greater, although earthquakes of this intensity are extremely rare in this area. The eruption of gas bubbles originating from base sediment layers could also play a role. Or a giant subsurface landslide on the edge of the canyon is a strong possibility. These three would be the most likely causes of a tsunami threat in this region. If you ever wondered how tsunamis are generated or what forces may be involved in this natural phenomenon, then here is a bit of useful information. Tsunamis, for the most part, are formed as a result of submarine earthquakes, but they can also occur as a result of the eruption or the collapse of coastal volcanoes, or from massive landslides in coastal areas that are most often triggered by earthquakes. The wall of water can be generated by the impact of the landslide as it enters the water, or as the water displaces behind and ahead of a rapidly moving submarine landslide, as shown in this Geoscience animated presentation. We know that historical data has shown that submarine landslides have occurred in the zones located across the Gulf of Mexico. But historical research also concludes that massive volcanic landslides have occurred several times in the Canary Islands off the western coast of Africa. Scientists have warned that similar events may occur in our future. A big landslide in the Canary Islands could generate large tsunami waves both at close and great distances, with the potential to inundate large coastal areas as far away as the eastern seaboard of North America. Back in the year 1755, a great earthquake believed to be in the range of 8.5 shook Portugal's capital, Lisbon. Not only did it leave the city in ruins, but it generated a tsunami 40 feet in height that surged up the Tagus estuary nearly an hour after the quake, which was then followed by 2 more waves. In Portugal's coastal city of Lagos, the tsunami reached a height of nearly 100 feet and severely damaged ports in both Spain and Morocco. Eventually, the tsunami wave made its way into the English Channel and then across the Atlantic. Rockfalls and avalanches along coastal inlets also have the potential to create regional tsunamis that pose a threat to coastal ecosystems and to populated regions. On July the 9th of the year 1958, a magnitude 7.9 earthquake located on the Fairweather Fault triggered a rock avalanche at the head point of Lituya Bay, Alaska. The landslide created a monster wave that ran up more than 1,700 feet on the opposite end of the bay. It then sent an unprecedented 100-foot wall of water across Lituya Bay. This simulation of the Lituya Bay event may provide a better understanding of the magnitude of the mega tsunami that was generated by the Alaska earthquake of 1958. If you reside along the U.S. Gulf Coast region or along the eastern seaboard, the prospect of sinking land and rising seas are not your only concerns. The threat of a tsunami has now joined the list of real threats for coastal residents. In perilous times, we must do what we can to protect ourselves, our families, and our loved ones. We do this through careful watch of any dangers or difficulties that may arise unexpectedly or with very little warning. By being vigilant, we find it easier to establish a barrier that keeps us at a safe distance from harm's way. Make it your practice to do all that you can to stay healthy and safe, so that together we may continue our journey on this planet. Thanks for watching.